Hello friends, welcome to our channel IPM Leap. Today's video lesson is on a question type which is very popular with question setters in entrance exams, and I have seen this question being asked repeatedly year on year in various exams. So today I am going to illustrate a few tricks that will help you solve such questions correctly and confidently in whatever exams you are taking. Let's go. Now, before I move on to various questions, here is a list of some basic algebraic equations, or I should say algebraic identities, that are going to help you tackle each and every question on algebra in the quant section of paper. So you may quickly revise these before attempting the questions. Okay, so our first question is, if x plus 1 by x is equal to 4, then find the value of x square plus 1 by x square. So students, in these questions, whenever we face an expression which looks like x plus 1 by x or x minus 1 by x, the basic scheme to solve this question remains the same. We square this given equation on both sides. So left hand side becomes x plus 1 by x whole square, and right hand side becomes 4 square, which is equal to 16. Now the left hand side is of the form a plus b whole square. So we may apply the algebraic identity a plus b whole square is equal to a square plus 2ab plus b square, where a takes the value x and b takes the value 1 by x. So our left hand side becomes x square plus 2 into x into 1 by x plus 1 by x square. Now clearly, in the middle term, x and 1 by x get cancelled out. So the resulting value of the middle term becomes 2. And so we can already see the two main terms on the left hand side are x square plus 1 by x square. Transferring 2 to the right hand side of this equation, we get the value of x square plus 1 by x square as 16 minus 2, which is equal to 14. So that's our answer. Similarly, if x minus 1 by x is given to us, we can find the value of x square plus 1 by x square easily by squaring both sides. Moving on to our next question, if x minus 1 by x is equal to 5, then we have to find the value of x cube minus 1 by x cube. So every time we face this equation, we have to work around this equation to achieve our required objective. In this case, finding the sum of cubes of these two terms. So broadly, our thought process should be that if I cube this equation on both sides, I will move closer to my objective, isn't it? So let's try doing that. Cubing this equation on both sides, we get x minus 1 by x whole cube on the left hand side, and the right hand side becomes 5 cube. 5 into 5 into 5, which is equal to 125. So whenever we need cubes, try and think of an algebraic identity which will give you cubes. Since we know that a minus b whole cube is equal to a cube minus b cube minus 3ab into a minus b, if we equate a to x and b to 1 by x, we shall get the cube of our left hand side, right? So let's calculate. Left hand side will be equal to x cube minus 1 by x cube minus 3 into x into 1 by x multiplied by x minus 1 by x. Now, do you remember what happened in the last question? In this case as well, x and 1 by x get cancelled out. And additionally, we can locate this expression in our original question, right? X minus 1 by x is given to be equal to 5. So we use that value here, and that's it. The remaining terms are x cube and 1 by x cube, for which we have to calculate the value. Let's simplify. X cube minus 1 by x cube will be equal to, and we transfer everything else to the right hand side. The signs get changed. 125 plus 3 into 5. 125 plus 15 is equal to 140. So that's the value of our required expression. X cube minus 1 by x cube is equal to 140. One more thing, as I told you earlier, even in this case, when we are given x minus 1 by x, we can simply square both sides to get the sum of squares. Let's do that. Left hand side square is x square plus 1 by x square minus 2. And right hand side square is 25. So sum of squares in this case can also be calculated easily if required. It will be equal to 27. Okay, so once we have mastered the squares and the cubes, the next step is to find higher powers of these two terms. So let us try out the question given on your screen. If x plus 1 by x is equal to 3, we have to evaluate x raised to the power of 5 plus 1 upon x raised to the power of 5. So guys, remember that for higher powers, especially odd ones, like in this case we have power 5, we must find squares and the cubes as intermediate steps. So let us do that. Squaring the given equation on both sides, we get x square plus 2 times x into 1 by x plus 1 by x square, which is equal to 9, where x and 1 by x get cancelled, and therefore x square plus 1 by x square will be equal to 9 minus 2, which simplifies to 7. And next, cubing the equation on both sides, x plus 1 by x whole cube is equal to x cube plus 1 by x cube plus 3 times x into 1 by x into x plus 1 by x brackets. Here x and 1 upon x get cancelled out, and the value of this expression x plus 1 by x is given to be equal to 3. So we use that. Our left hand side gets simplified to x cube plus 1 upon x cube. The right hand side becomes 3 cube, which is 27 minus 3 into 3, 9. 27 minus 9 is 18. Therefore, x cube plus 1 upon x cube is equal to 18. Now look carefully. The powers of both terms in this expression is 5. And recall, if we multiply x square and x cube, what do we get? The powers get added up. So we will get x raised to the power 2 plus 3. That is x raised to the power 5. This is the product rule of indices that gets applied here. So let's multiply squares and cubes and we will surely get closer to our objective, right? Well, don't be afraid of experimenting. Even if you don't succeed at first, it's always a good learning experience, right? So multiplying, we get x square into x cube plus x square into 1 upon x cube plus 1 upon x square into x cube plus 1 upon x square into 1 upon x cube. The two middle terms can be simplified further because a lot of x's are common. Square and cube resulting will be a simple 1 by x, and similarly here we will get a single x. So see, the middle two terms get clubbed into x plus 1 by x, which we can see from the original equation is equal to 3. We use that, and x raised power 5 plus 1 upon x raised power 5 simplifies to a value of 126 minus 3, which is equal to 123. So that's our answer for this question. Yeah, so here I will reiterate the point that using the squares and cubes as intermediate steps, we can always find higher powers. For instance, in this question, if you are asked to calculate x raised power 4 plus 1 upon x raised power 4, we just square the squares. This equation, squaring on both sides, we get x raised power 4 plus 1 upon x raised power 4 plus 2 into this term into this term, which will get cancelled out obviously. So resulting will be 2. Right hand side square of 7 is 49. So x raised power 4 plus 1 upon x raised power 4 simplifies to a value of 49 minus 2, which is 47. And just in case they ask you power 6, which is very rarely asked though. So a simple hint is to either calculate the cube of squares or else calculate the square of cubes. Square this equation on both sides and you will get your answer in 2 seconds flat. But even if you choose to cube the squares, cubing this equation on both sides, we get x raised power 6 plus 1 upon x raised power 6 plus 3 into, these two terms get cancelled out, into x square plus 1 upon x square. This value is equal to 7, so we use that. And our answer for x raised power 6 plus 1 upon x raised power 6 is 343 minus 21, that is 322. Right, so I am sure you have learned the basics already and you can tackle these questions confidently from now on. Now, in a few odd questions, they might ask you the power 20 or maybe even power 100. Don't worry, there is a catch in such questions because they certainly don't want you to calculate squares or cubes over and over again. So let us say x square plus 1 upon x square is equal to 2. And they have additionally given that x is greater than 0. By the way, if they give you x square plus 1 upon x square, you can always do a reverse step to calculate x plus 1 upon x. How so? Just add 2 on both sides. So left hand side, 2 can be written as 2 into x into 1 upon x. Right hand side, we get 2 plus 2, which is 4. Left hand side becomes x plus 1 upon x whole square. Therefore, taking square root on both sides, x plus x, which will be positive, is equal to 2. This equation gives us a unique value of x, which for a change is not a complicated surd. Now surds are irrational numbers and a little scary for my students, I know that. So look, this equation is the same as, isn't it the same as x square minus 2x plus 1 is equal to 0. What are the roots of this equation? This quadratic equation means x is equal to 1. The roots are 1 and 1. So no matter what power of x is raised, once we put 1 here and 1 here, the resulting value of this expression will be 2 always. So that brings us to the end of this video. On your screen is a sneak peek into the contents of our next video. If you enjoyed this one and found it useful, don't forget to press the like button and subscribe our channel. Keep watching and take care. Bye-bye.